Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today we're going to go over a problem regarding to rotation. Here is an example. So a student holds one end of a thread which is wrapped around a cylindrical spool as shown. The student then drops the spool from height h above the floor, and the thread unwinds and it falls. The spool has a mass m and a radius r, and the thread has a negligible mass. The spool can be approximated as a solid cylinder of moment of inertia I equals 1/2 mr squared. Express your answers in terms of m, r, h, and fundamental constants. Part 1. Calculate linear acceleration of the spool as it falls. Since we have to find the linear acceleration, we have to use Newton's second law. So to use Newton's second law, the first step is to do a free body diagram. So here are the forces acting on the spool. When the spool is falling, you'll have tension going up and you'll have gravity going down. Newton's second law says sum of the force equals ma, sum of the torque equals I alpha. The sum of the force is just mg minus t. I use mg minus t because the spool is accelerating downward. That's why I use downward as positive. For the torque, mg does not produce any torque because it's past the center of rotation. The only force producing the torque is the tension. So we have these two equations. Here is I, and alpha equals a over r because it's rolling without slipping. We can cancel out r. So if t equals to 1/2 ma, substitute t in the first equation and add 1/2 ma on both sides, then you can solve for a. That's a equals to 2/3 of g. By the way, you can also cancel out mass, make it easier for you to do. Part B, calculate the angular velocity of the spool just before it strikes the floor. So when it comes down, what is the angular speed, rotational speed? There are a couple ways to do it. You can use conservation of energy. Over here, your energy is mgh. Over here, you have kinetic, which is 1/2 mv squared plus 1/2 I omega squared. And we know v equals r times omega. So you can do it that way. That's probably easier. But I did this way. I used linear components to figure out the final velocity because I know the initial velocity is 0. I know acceleration. I also know the height. Whenever you know three things, you can find the rest. So the final velocity, once I have the final velocity, I use the omega equals vf over r. So this is the equation I use to find final velocity. This equation is also called the timeless equation because we don't have time in this equation. Substitute your a in, substitute your vi, which is 0. So you have vf just equals 2ah. A is 2/3 g. So this is your vf. Substitute back, you have omega f equals 1 over r times vf. So this is the same. Okay. Now at the time t equals 0, the spinning spool is still spinning, right? Lands on the floor without bouncing, comes free from the thread. It continues to spin but slips on the floor surface. While doing so, assume constant sliding friction mu. Calculate the angular velocity of the spool as a function of time. Because it's still spinning, and due to friction, that spinning is going to become less. Okay, so first, due to the tension, we know it's spinning. This is counterclockwise. So when it's on the floor, it's still spinning counterclockwise. But now you encounter friction. Friction is always opposite your motion, oppose the motion. So friction is going to slow this down. This is a free body diagram. To find the angular velocity, we have to use Newton's second law to find angular acceleration. Remember, this angular acceleration is retarding acceleration or slow it down. So the friction produce negative angular acceleration. So here is F times R, that's the net torque. And here is I times alpha. Alpha should be negative. So from here, m and m cancel, r and r cancel, your alpha should be negative 2 mu g over r. Remember, you're starting with omega I, which is the omega you got from before. You were spinning. So this omega naught is the one we got before, which is 1 over r square root of 4gh over 3. Alpha is negative because the friction slows it down, minus 2 mu g over r times t. This is a function of angular velocity as a function of time. D, calculate the horizontal speed of the spool as a function of time. Assuming the horizontal speed is 0 at time t equals to 0. Because when it dropped, originally it has vertical speed. It does not have any horizontal speed. That's why the speed is 0 when it reaches to the floor. So to find horizontal speed, we use the same idea. We have to find horizontal acceleration. Because the speed is 0, the friction produce acceleration. This is going to, the friction actually is going to speed it up because speed was 0 before. Now, cancel m, a equals to mu g. Since v naught equals to 0, so v is just equals to mu gt. This is v as a function of time. Last part, at what time does slipping between the spool and floor stop? When it stops, that means it's rotating without slipping. That means this equation holds. V equals r times omega holds. We know what v is. We know what omega is. You said 2 equals to each other. You can solve for t. So from this equation, you can see all the r cancels out. You add 2 mu gt on both sides. Then you solve for t. Divide by 3 mu g on both sides. You can simplify this equation. You will have this g is basically square root of g squared, right? Then this g and this g cancels. So it becomes 4h over 3g. That's it. I hope it helps. Thanks for watching. See you next time.